Okay, so the next example we're going to do is nice and short, but it's just to emphasize that we can apply L'Hopital's rule as many times as we need until we get to a point where direct substitution does become a viable option to solve our limit. So we're just going to start with the limit as x approaches infinity of e to the power of 3x over x squared. And obviously I can't just plug in infinity because I end up with infinity divided by infinity, and that's indeterminate. But what I can do is apply L'Hopital's rule. So I have the limit as x approaches infinity of 3e to the 3x, right? Because the derivative of e to the 3x is just going to give me this, and then the derivative of my exponent over 2x, which unfortunately still doesn't work out, right? If I just plug it in now, I'm still going to have an indeterminate form, but I can apply this again and use L'Hopital's rule one more time. So I get the limit as x approaches infinity of, again, applying the same thing, 3 times the derivative of this, so in total 3 times 3 is equal to 9, and e to the 3x over, now it's just 2. Right? I don't have a variable in the denominator anymore, so now direct substitution becomes a valid choice. And because I just plug in infinity, I have infinity divided by 2, but the division by 2 doesn't change anything, so my answer is just infinity. Right? So a really nice, straightforward example of how you can apply L'Hopital's rule more than once to solve your limit. Okay? So let's do another example. For all these examples, by the way, I'd encourage you to, if you don't know the solution right away, hit pause, give it a try, and then unpause at least after you've tried to solve it, so that you can see if you did it right, or just give the question a try first. So slightly more complicated, 4x minus 2 sine of 2x, all divided by 5x cubed. Now, obviously, I have already given away that it's kind of the similar strategy, but when I see an expression like this, the essential warning bell that goes off in my head is I look at this denominator, and I see that it incorporates x, and so does the numerator. So I'm kind of thinking something has to disappear, right? Ideally, I'm going to end up with a denominator that no longer has a variable in it, so that direct substitution becomes an option, and that's exactly what I'm going to do. So obviously here, if I plugged in 0, I would just get 0 over 0, so I have an indeterminate value. But taking my derivative, so applying L'Hopital's rule once, I end up with 4 minus 4 cosine of 2x over 15x squared. And unlucky me, I run into the same problem, so I do it again. Limit as x approaches 0 of now 8 sine of 2x, right? I don't have two terms anymore because the 4 has disappeared. It was a constant. And now I have 30x. And now I'm almost there. I have x just to the power of 1, so I just need to apply L'Hopital's rule one last time. So I get the limit as x approaches 0 of 16 cos of 2x over 30. Right? And now I don't have a variable in the denominator anymore. Substitution becomes a valid method, right? Because when I plug in 0 here, cosine of, well, 0 is just going to be 1. So I'm just going to be left with 16 over my constant that doesn't change of 30, and I just need to slightly simplify my fraction to get my final answer, right? Okay, so that's how you can use L'Hopital's rule multiple times to solve examples like that. Okay, so there should just be one slightly longer video incorporating 3 examples that we didn't get a chance to finish yesterday. Again, they're all pretty quick before we get into our IB question solutions.